Hey kiddos, hope you're doing well. I'd like to continue this problem we started today and kind of pull some ideas and reiterate some ideas pertaining to slope and equations of lines. So here we go. We have two ordered pairs, and those ordered pairs look like, I think today instead of calling that the year 2012, we let X be the year after 2012. And the Y value, I think we decided, was going to be the millions of iPhones sold in that particular year, right? So we're establishing this, in this case, just two ordered pairs that relate the year after 2012 to the millions of iPhones that were sold during that year, okay? And then we're going to establish we're going to assume some sort of linear relationship between them and use that information, okay? So that said, the first point instead of 2012 becomes 0, and then 125 million. And the second point instead of 2013 becomes 1 year after 2012 and 150.2. Right? And so here are the two coordinates, and we graphed them here. Right? And you could certainly graph them on a piece of paper, but we did this in class today, so why do it again? Okay. Now what I want to do is find the slope of the line between those 2 points. And remember, slope is rise over run. Slope is change of y, in this case m, which is slope, is going to be change of y. Now my y is millions of iPhones sold. So it's change of iPhones sold in millions per change in x. And my x in this case is year. Per change in year. Right? So what I want to establish is, well, what the heck, how can I quantify those values, right? So change in iPhones is just the difference, 150.2 minus 125. And of course, we're in millions, divided by change of x. So 150.2 minus 125 divided by 1 minus 0. And of course, that's 1, but we'll write it out. Right? Change in iPhones, change in year. Right, and that gives me, no uncertain terms, 25.2 over 1. And now because it's a particular context of this problem, it's millions of iPhones per year. Right? So there's my slope. Now, that's meaningful, right? That slope is meaningful because it tells me if I assume a linear relationship between the 2 points, then the rate at which I'm increasing my iPhone sales is 25.2 million additional iPhones per year. Okay. Now we already talked about the midpoint today, but I do want to spend some more time talking about, okay, let's find the equation of the line, because that was a bit sticky today, right? So let's focus on how on earth we can find the equation of the line that travels through these 2 points, okay? And I'm going to present a couple different options, okay? One option is to use slope-intercept form, which looks like this, right? And recall this is a linear function with slope m and y-intercept b, okay? And so the nice thing is I already have the slope of the line that travels through these 2 points. I already found it to be 25.2. So I can plug that in there right now. And now what I want to find is, well, what on earth is the y-intercept? Right? And of course, something I should mention is that y in this case is the millions of iPhones sold, and x in this case is the year, right? Independent year, dependent iPhones and millions sold, right? So I need to nonetheless solve for b. Now there are a couple ways to do it, right? Sometimes I would have to take either one of the 2 points it travels through, the line, plug in the x and y value, either one of the points, and then solve for b, right? That's usually how we would solve for b. In this case, however, it's a little bit easier than that because I already have the y-intercept, right? The y-intercept is the y value when x is 0, and I already have that, right? It's 125, right? This is the y-intercept, right? So I can just plug in 125 for b, right? And so that's one way to get the equation of the line that passes through my original 2 points. Right? Another way to do it would be to use my favorite, point slope. right? Y minus y1 equals m, the slope, times the quantity x minus x1, right? Now this is called point slope because it asks us to input the slope for m, which I already know is 25.2 millions of iPhones per year, and a point x1, y1 through which it travels, right? So the point through which the line travels goes in for x1, y1, any of the points really. So I already have the slope, 25.2, right? And now I just have to take either one of these 2 points through which the line travels, right? And if you do it correctly, you'll get the same solution no matter which point you choose. Now it's probably easiest to use this point, 0, 125, right? So the 0, the x value, goes in for x1, right? So 0 goes here. And then the 125, the y value, goes in for y1, goes right here, right? So now, I mean, that is the equation of a line. I could certainly clean this up, distribute the 25.2. Well, really not to the 0. It doesn't make sense. Don't have to. And then add 125. And up, lo and behold, when I do that, you get the same thing. Slope-intercept form. Okay? So this is point-slope form that asks us to plug in a point, in this case 0, 125, through which the line travels, and a slope m. And this is slope-intercept with our slope, coefficient of the x, and the y-intercept. Okay? And they're both the same in this case. They just look different. And they will be the same in all cases if we do it correctly. Okay? Now I'm going to use those lines that I have to answer the rest of the questions. The x and the y-intercepts. Well, we already talked about the y-intercept. It's 125, right? Right? So the y-intercept is 0, 125. So 0, 125, that's the y-intercept. Right? And that was a starting point. So according to this point right here on the graph, I start when x is 0. The sales when this data, and there are only 2 points, but when this data starts, there's 125 million iPhone sales. Right? The x-intercept is the value of y when x is 0, right? So take this equation right here. And so, excuse me, the value of x when y is 0. So to find the x-intercept, I want to plug 0 in for y. And it doesn't matter which of these 2 linear functions I use, they're the same. So to find the x-intercept, I'm going to plug a 0 in for y, right? So 0, I plug a 0 in here. Actually, I'll write it right under it. 0 equals 25.2x plus 125, right? And I can solve for x. I'm going to subtract 125. So negative 125 pops up on this side. And then I'm going to divide by 25.2, right? So if I quit this, negative 125 divided by 25.2, which is our slope, is negative 4.96, right? So therefore, negative 4.96, comma 0 is my x-intercept. Okay. Okay, now let's get a little fun, right? And this, of course, it would mean the this would mean the year during which we sold 0 million iPhones. Now let's kind of use our equation of a line, either form. They're both the same. It's kind of annoying to see the minus 0. It's kind of not necessary, but regardless. We're going to use that equation of the line to predict iPhone sales in 2025, right? So I'm going to y equals, I'll just rewrite the equation of the line. Y equals 25.2x plus 125. So 25.2x plus our y-intercept of 125, right? So in this case, I want to use the equation to predict the sales in 2025. Now sales during this year, remember year is my independent variable, that's x. But I'm not going to put 2025 in because if you recall, x, my independent variable, was the year after 2012, right? So that would mean I'm not putting in 2025, I'm really putting in, that's right, 13, right? 13 is the year after 2012, right? So I'm going to put in, instead of 2025, I'm going to plug in for x 13, okay? And then on my calculator, 25.2 times 13 years after 2012. Basically, every one of those years, 13 years, I'm increasing 25.2 million iPhones in sales per year. And then plus my original 125 million sales gives me 452.6 million iPhones. Right? Now, I'm making a huge assumption here, right? I'm making the assumption that, in no uncertain terms, the rate at which iPhones will continue to grow will be the same. In that case, 25.2 million iPhones per year will continue to evolve and increase at that rate, right? Which is a huge assumption, right? Just based on 2 points, just based on my initial 2 points of the year 2012, 2013. Okay, so is that legit? I don't know. I wouldn't bet my job on it for sure, right? But as long as I understand the assumptions I'm making, however, that's fine. Okay. Now I want to finish this up. I want to use the equation line to predict when iPhone sales hit 1 billion, right? So that means instead of plugging in for my independent variable now, I'm going to plug in this value for my dependent variable. Whoops. So here's my original equation of the line, right? Remember, y is the number in millions of iPhones sold. So if I want to know when, I'm trying to solve for x, I hit 1 billion, I'm not going to plug in 1 billion. I'm not going to plug in 1 for y. I'm going to plug in 1,000. That's correct, because remember, my y value is in millions, right? And 1,000, therefore, would represent 1 billion. Okay, so now I'm going to solve for x. I'm going to subtract 125. So 1,000 minus 125, and I'm going to divide that answer by 25.2, and I get 34.72. X equals 34.72. And what's my label? Well, I'm talking x, which is years after 2012, which would make it the year essentially 2046, almost the year 2047. Okay? What assumption am I making? Again, I'm making the assumption that iPhone sales will continue to grow at the same constant rate of 25.2 million per year. That's a huge assumption. Okay, is it legit? Well, not really. It's not legit because I'm only basing it on 2 points, 2 initial points. Okay, so some things to think about: slope, the function as a line, what it looks like, the x-intercept, y-intercept, how we can use it. Okay, thanks for listening. Hope this was helpful.